Hello, Integrated Math 1 students. I just wanted to reach out to you and say this will be our Unit 8 review for Integrated Math 1. My goal is to go over the problems and let you step by step see the solutions and how we work the problems out. And then essentially you will try them on your own and basically go from there and get ready to test for Unit 8. I really appreciate all your flexibility in this challenging time. Just know that I'm here for you. I know the rest of the staff is also here to help support you. As I go over these problems, you probably won't see my face because the way I set up the camera is to directly see the whiteboard. So I'm going to start doing the multiple problems step by step of the Unit 8 review, and then I will post them to my YouTube channel for you. All right, so let's begin. So problem 1 is a coordinate geometry problem. It says classify triangle ABC with vertices A being at -2, -1. So we have vertex A being at -2, -1. We have B being at -1, 3, and we have C being at 2, 0. So those are the vertices of the triangle we are looking at, and it wants us to classify this triangle as either scalene, equilateral, or isosceles. So we have the definitions of 3 triangles. We know them. So for scalene, all that I want you to remember is that the lengths of each of the 3 sides of the scalene triangle are different. So the lengths of each side is different. And for equilateral, we know that for an equilateral triangle, the lengths of each of the sides are the same. And we also know that for an isosceles triangle has 2 side lengths of the triangle that are the same. So the length of 2 sides are the same. So as we went over this earlier, this is very important. So for a scalene triangle, again, the length of each side of the triangle is different. For equilateral, the length for each of the sides are the same. And for isosceles, the length of 2 sides of the triangle are the same. So now we're going to graph. We could graph these at the very end, these coordinates, but essentially, in order to see if the side lengths are different, if they're the same as an equilateral triangle or isosceles, we're basically going to use the distance formula. And if you recall, the distance formula is going to be the square root of one coordinate, x squared, or x2, minus the other coordinate, x1 squared, plus y2 minus y1 squared. So again, the distance formula is one of the x coordinates, subtracting the other squared, plus the y coordinate and subtracting the other y coordinate squared. So what we want to do is we are going to find the length of AB. We're going to find the length of AC, and we're going to find the length of BC. And if we find those lengths using the distance formula, we will determine if this triangle that's formed by these three coordinates is a scalene, equilateral, or isosceles triangle. So for AB, we have two coordinates. We have coordinate A that's at -2, -1, and coordinate B that's at -1, 3. So we're just going to plug this formula into the distance formula. So what we'll do is go the square root, and we're going to take the one of the x coordinates. So I'll just take the first one and go -2 minus the second x coordinate, which is -1. We're going to square it, and then we're going to do the same thing. Since we started with -2 for our x, we're going to take -1 for our first y coordinate, and we're going to subtract the other y coordinate, which is 3, and then we're going to square it. Okay, so when we do the math for this, we're going to have -2 plus 1, so that's going to be -1 squared plus -1 minus 3, that's going to be -4 squared. Doing the math, we're going to get 1 squared plus 16, so that's going to be 1 plus 16, which is 17. So length AB is going to equal the square root of 17. All right, so now that we found the length of AB, we're going to now find the length of AC. So we take the coordinate for A, again, that's -2, -1, and we are going to take the coordinate for C, which is 2, 0. Now, what we're going to do for this problem is the same thing. We're going to plug these two coordinates in the distance formula. So the first x coordinate we have is from coordinate A. That's going to be -2. And essentially, we are going to then subtract the second x coordinate, which is 2. So we're going to have -2 minus 2, square that, and then we're going to add y, which is -1 minus the second y coordinate, which is 0. And then that's going to give us -1 minus 0. So we're going to have -2 minus -2, that's -4 squared, plus -1 minus 0 is -1 squared. Doing the math, 4 squared is 16, plus 1 squared is 1. So again, for AC, side AC is going to equal the square root of 17. Now if we notice, AB and AC are the same length. So we at least know that this triangle could be an isosceles because the length of two sides is equal to the square root of 17. But we can look and we have to determine the last side, which is BC, because if BC is equal to the square root of 17, then all three sides are the same. And if all three sides are the same, then we know it's going to be an equilateral triangle. So we are going to take the first coordinate for B, which is -1, 3, and we're going to take the coordinate for C, which is 2 and 0. And now we are going to use the distance formula again. So we're going to have, right there, we're going to have -1 minus 2 squared plus 3 minus 0 squared. Doing the math, -1 minus 2, that's going to give us -3 squared, plus 3 minus 0, that's going to give us 3 squared. Doing the math, -3 squared is 9, plus 9, that's going to give us the square root of 18. Okay, now if we notice, we have a triangle with one side being the square root of 18, and the other two sides are the square root of 17. So because we have two sides that are the same in length, we know I'm just going to label this triangle. We're going to have A right here, and we are going to have, I'll put B right here, C right here, and then A at the top. So we know that because two side lengths are the same, this triangle is going to be an isosceles triangle. So this is problem 1 on the Unit 8 review. Let's see if you could see that. Okay, right about there. Awesome.